Assalamualaikum and very good morning. My project is Centralities and Spectral Analysis of SARS-CoV-2 Human PPI Network and Twitter Network. So as an introduction, what is a graph? So graph is a set of vertices and also the set of edges, where we have a set of nodes and also the set of edges. And we can apply it to any model. And in this research, we focus on proteins with their interactions as a graph, or we call it network, and also Twitter users with the communication between users as a network. So if I want to ask another question is, which of these nodes is the most central? So node 3 is very important in between the centrality, but not node 1. And if I want to ask another question, which nodes that we have to collect together to form a community, so which edge should we cut? So basically, it's obvious because we can come up with a triangle and a square. But in 1973, Fiedler already studied about the Laplacian matrix and the application of the second smallest eigenvalue of the Laplacian matrix, and it has the sign of the entry. If we group together, it form this cluster. So it can be applied to a very complex network. So the problem statement is that the COVID-19 pandemic and the concurrent rise of social media during MCO has underscored the significance to understand the structure of biological network and also the social network. Basically, it's a protein network which involves a protein of the COVID coronavirus and human, and also the social network which involves the Twitter users network. So in literature review, the protein network analysis basically come up with the idea to find the key proteins using centrality and also performing functional analysis from the statistical point of view to understand which biological process is much greater expressed. And from the perspective of Twitter network analysis, the top influences are expressed using centrality, and also the algorithm to find the community using modularity optimization of CNN, also Leuven algorithm. So moving to spectral graph theory, what is interesting about spectral graph theory that we can answer a question of, if we have a matrix or matrices associated with the graph and we study the eigenvalue and eigenvector of those matrices, what are the characteristics of the graph that we can know? And in 1973, Fiedler introduced the concept of algebraic connectivity defined by the second smallest eigenvalue of the Laplacian matrix and the corresponding eigenvector, which is now goes to his name because of his contribution. The Fiedler vector becomes the spectral graph that I showed earlier. And clustering problem rely on graph partitioning problems, where we have to cut edge. So in 1993, the basic idea is to minimize the cut, but it always comes with the isolated nodes problem. So the more modern idea is to apply normalized cut threshold for the algorithm of bipartitioning recursively. The normalized cut will ensure that we have very many edges between the same communities and very minimal edges between different communities, because we now have two components of the subgraph 1 and subgraph 2, because in Fiedler algorithm we are actually bipartitioning the graph into two subgraphs. And then normal algebra tells about modularity, and then comes the Leuven algorithm that optimizes the modularity. The spectral analysis also has done from the perspective of eigenvalue degeneracy, where the eigenvalue of the characteristic polynomial, which is the root of the characteristic polynomial of the adjacency matrix, appears many times. So there has been a research gap in combining both the centrality and spectral graph theory for the biological network and also the social network. So the objectives of this study are to analyze the centralities of proteins and also users, and also to investigate the spectral analysis from the perspective of eigenvalue degeneracy and also spectral clustering. So we have to begin with the processing of two data sets. This data set comes from the biogrid to get the protein of coronavirus and also human interaction, and also using the data of tweets on 1st February 2021 that has fitted PKP only, that has the word PKP only, that we can model as a network. Then adjacency matrix is built. Adjacency matrix tells the information of which node is adjacent to which node. So it's only made up of 1 and 0. So 1, it tells us if there is an interaction between proteins, and also there is a communication like tweet, mention, and code between users. So the centrality study a degree, cross-centrality, and between centrality. For the spectral graph theory, it all roots from the rank nullity theorem. For any n by n matrix M, the rank of the matrix plus nullity of the matrix equals the number of columns. So the rank is the number of linearly independent rows. So we have to search for the linearly independent rows, or the special case of linear combination of rows, rho I equals Rj. So that is lead us to the concept of geometric multiplicity of M minus lambda I, where lambda is the eigenvalue of the adjacency matrix, and also algebraic multiplicity, which is simply the number of times lambda is repeated as the root of the characteristic polynomial of the adjacency matrix. So from the adjacency matrix, it's a row combination. But when it comes to graph, it's actually not duplication to eigenvalue degeneracy. So the zero eigenvalue degeneracy tells us which node is duplicated. As you can see, the blue nodes has the exact same set of neighbors. Also the red node, but with additional each between the duplicated nodes. So Fiedler, applying the Laplacian matrix, which is the degree matrix minus the adjacency matrix, and we have to find, okay, there is a theorem, it's a very important theorem. If G is a connected graph and L is its Laplacian matrix, the smallest eigenvalue will be 0, and it indicates a connected graph. And the second smallest tells us the information of the connectivity. The second smallest goes to Fiedler value, and the corresponding eigenvector is the Fiedler vector, and we have to group together the similar sign. And then we do it recursively with the normalized cut threshold. So as you can see, this is the protein network. It is a more central network, where in the center are the COVID-19 proteins, and the peripheral nodes are the human proteins. And this is a Twitter network. We can see a very different structure of the network just from the protein. Okay, so basically both networks have roughly the same density. Okay, going to the main highlights of the centrality. If you can see for proteins, the top 8 proteins for COVID and also the top 8 protein for human, the closeness centrality are quite close to each other. What does this mean? So protein with high CC is actually showing that it has the shortest distance to influence many other proteins in a small number of interactions. So these proteins are very important if you want to target drug to this protein, so that the drug can reach the whole network quickly. The strong positive correlation between degree and CC indicates that human proteins are accessible targets for COVID, for the SARS-CoV-2 virus. And the close scores between human and COVID-19 proteins indicate that if any disruption causes a virus, it can lead to very rapid and systemic effects to the host cell. So going to BC is a very different nature. The human protein have almost 0 between centrality, which indicate that human proteins are not acting as connector. Or if we tell about BC, the higher BC of the protein, the more the likelihood of the protein to participate in the biological pathway. So all human proteins are the interaction points or the targets for the COVID-19 rather than they become the connection, the connector. So we also utilize Metascape to understand the biological functions of those proteins with a high CC, high degree, and high BC of the human proteins. And it ended up that the three hubs groups are all important in metabolic processes, cellular processes, and response to stimulus or immune system. So going to Twitter network, the high degree users, the top three are not governmental account, but they voice out important issues during MCO, like economy issues and also economic and social issues about health and also welfare. And we can also see some of the government authority in the high degree score, which is the former Minister of Defense, Ismail Sabri, Jabatan Penerangan, Bernama.com, the mass media, police, and also Ministry of Health in the list. In terms of between centrality, there exists some user which have very low degree but very high BC, like Afdrizan, Nizam Achiba, and Hafiz Zaidi. We can also see that the group of a government account still remain prominent in terms of BC. So what does this mean? A high BC score of not acts as bridge for information flow in the network. Okay, and now the former Prime Minister of Malaysia start to be in the list, and we call the special individual as quiet relays, who have high BC but low degree. So what is the special about quiet relay? Quiet relay turns out to connect through minimal connection between different communities. These are the communities assigned using Fiedler algorithm, and the green one is the community of the government account, and the orange is the community of the high degree user, and also this is another community. So using 9 connection, Altrizan actually connect the information from 3 communities using 9 significant and strategic connection. Okay, so now we move to the second objective, which is the spectral analysis. As we can see, the protein adjacency matrix has a very high degeneracy or algebraic multiplicity of eigenvalue, which is very small, which is very close to 0, 98% in fact. And there is no -1 eigenvalue. But for Twitter network, the adjacency matrix has 60% of the eigenvalue, which is very small, and there are some of the eigenvalues which is -1. So looking for the row duplication, and we have another -1 for Twitter. So for eigenvalue degeneracy, what is interesting is that duplicated nodes have the same set of neighbors. So this will bring us to the idea of identical topological property. All duplicated node has the same CC, same degree, same BC, same cluster assignment, and this will imply topological symmetry within the network. So if I can tell you, these proteins are duplicated and their functions are the same. Also, these are also duplicated, but the functions of COPB2 are still unknown. So we can use this to infer the function of COPB2 based on the function of FSCN1. So, but however, only small proportion of hub are duplicated. So why must we bother? We must take into account the equilibrium degeneracy because at least 45% of the proteins are duplicated. So if you are to fight infection, we have to focus on the hubs and also the duplication, because if not, the protein will survive because there are so many duplication occurs in terms of interaction. So going to the spectral clustering results, we perform Leuven algorithm to know roughly how many clusters that Fiedler clustering have to produce. So based on this Leuven, we come up with the normalized cap of 0.9 for protein network and also normalized cap of 0.535 for the Twitter network. and we have produced 8 modules which is close to Levin algorithm, and also 38 communities which is close to Levin algorithm. Even though the modularity are lower than the Levin, but the feeder spectral clustering identifies major clusters, where the clusters are based on the function in the protein network, and also the clusters for Twitter network are based on the issues that around in the cluster, and also the governmental hierarchical cluster. So in conclusion, centralities play different roles in both networks. Hubs are strategically positioned in the protein network, and that the hubs is critical for the virus to hijack the human network, human cellular processes, and Twitter network demonstrate weaker correlations between centralities, suggesting a more complex and diverse interplay of user roles. While spectral analysis further distinguish the two networks, in biological, we have to consider the eigenvalue degeneracy because attacking both can collapse the viral network. And in terms of spectral analysis, the star-like modules in the protein network reflect functionalities, and also the Twitter network, we have more diverse nature of social interaction of tweets. This is the references. Thank you.
I have a question about human protein versus SARS-CoV protein. But they are all protein that can be in the human, right?
Yes.
So why is it called human protein versus different kind of protein?
Why?
Protein ni semua dalam human kan?
Yes.
Tapi kenapa ada nama human protein? You cakap human protein tu lain.
Yes.
Nama dia lain. Kenapa dia jadi macam tu?
Because it's for the analysis of functional analysis. There are 4,000 plus proteins in the network, and only 31 proteins are COVID-19 protein. Only 31. The rest 4,000 are human proteins.
But so the SARS-CoV protein is in a human protein?
In the human. But we are concerned with the human protein. Why? Because we want to send the top 10% of the hubs of this interaction of the centralities into Metascape to know the significant biological processes.
Basically, you wanted to separate lah.
Yes,
some COVID proteins dengan other proteins lah. Macam tu. So, tapi tak adalah orang panggil human protein kan? Is it called human protein? I mean,
Yes, dia memang human proteins.
Dia memang panggil human protein.
Because in the Metascape we have to follow the species. If this is not human proteins, then the result will not have the result.
Yeah, but my concern is because it's two groups. Yang SARS-CoV tu pun dalam human juga kan? But it's just you want to call this other group something and you put in the Metascape, right?
Yes.
Tak apa. The naming thing tu, I just wanted to understand why you call it. Sebab SARS-CoV tu pun orang tengah argue kan sekarang dia punya asal usulnya daripada mana? Lab ke haiwan? So, I mean, itu satu kontroversi yang besar lah. Cuma yang kita tahu protein tu ada in human. Okay, so that's the first question lah. So the second one is, what is your motivation to compare SARS-CoV protein dengan Twitter pula?
Okay, the main motivation is to test the Fiedler vector itself, because the Fiedler vector works with small graphs. So we want to see the real world network whether it works or not, and it seems it works because in the protein network it classify or it groups based on the function. If not, why Metascape produce a very specific functions for those in the same clusters, and that's for the protein. For Twitter network, it managed to find the major clusters, which is the cluster of high degree users, the clusters of the high degree users, star network, and also the clusters of governmental, which is very dynamic. We have the source, and it goes to, we have the Prime Minister, we have the Ministers Ismail Sabri, and then it goes to the mass media bernama.com, and it goes to the Ministry of Health.
Okay, but then you said you run the Luban algorithm first.
Yes.
To get the number of cluster. So the Luban algorithm didn't already give this
Yes.
modality.
The Luban algorithm already give this.
So why do you want to
The objective is not to find the optimized cluster, because we already have Leuven algorithm. But we want to test the spectral cluster, the spectral clustering method.
Okay, so sebenarnya dah dapat dah. Sama, lebih kurang.
Lebih kurang.
Okay, as I suspected lah. Okay, tapi and then moreover you needed to know how many to target, because you said you
Yes,
run first
that's
Luban
right.
algorithm, dah dapat dah, tapi you use the number of modular cluster from Luban algorithm so that you can adjust Fiddler punya. Is that true?
Yes, true.
Yeah. Okay. So, okay, another question is, sebelum ni tak ada orang test ke Fiddler punya cluster ni?
For my reading, tak ada. It memang very limited, because the Fiddler, it's in 1973, and there are some proving why Fiddler method works in 2012 by Justin, but the application to the real world network has not been done.
So, from if I understand correctly, Fiddler can cluster, but it seems that the result is more or less the same with Luban.
Yes.
But I think the connection with Fiddler is interesting because of the eigen vector, the
Yeah.
eigenvalue. You can easily extract just from looking at the eigenvalue without having to do the clustering. You can have some idea about what will happen lah. Yeah. As opposed to Luban algorithm, you don't have any eigenvalue connection lah.
Yes.
I think that's a question that I think I understood correctly from your writing and presentation.
Aiman, I have a question. Betweenness tu kan? So what's the range? The high and low tu, what's the range? I think maybe page 40 plus, 42 ke something.
For protein.
Yeah. Yes. No, I think before that or after that. The 0 point. Yeah, before. Okay, before one side before. Okay. The highest one is 0.4. The lowest is somewhere between 0.04. Here, this one. For the Twitter, right? So, what is the range? Because is this, you said these are all the high betweenness, right?
Yes.
So what is the range? Because the first one is 0.7 and the lowest is about 0.02.
The range is 0.72, because there are nodes, there are users who have zero betweenness centrality.
Who has zero?
Zero betweenness centrality. The minimum is 0.
So more than 0 considered high.
In this network.
So but depends on shortest path. I mean dia tak ada macam correlation. So dia just relative measure je lah.
How about for the protein?
Yes, the highest is 0.15, and very close to 0, and it leads to 0. It will go to 0.
So this considered high.
Yes.
Betweenness.
Yes, because it's a star network. It's a star network, and it has a preferential attachment, a preferential attach a preferential characteristic. The more the degree, and it will become more and more. And that is the COVID-19 protein. It will become hubs. So the human protein at the periphery will not be a bridge for any shortest path.
So, what can you tell me between these two so-called cases, the human-human interaction and also the social media interaction? So, do they the same? That's, I think, what I get from your presentation, right?
And no, they are not the same.
They are not the same.
They are not the same.
Based on?
Based on the centrality, just like using between the centrality, we can see the score is very low, 0.15
Okay.
as the maximum, and for the Twitter user case it is 0.72. So if we want to take the shortest path in the Twitter network, the role of the nodes have become more excellent in between the centrality in passing through become bridge for the shortest path for any pair of nodes. Pair of nodes. But in protein, that is not the case because it's very low, 0.15. Because we can also think it's logically because the protein are in the center. So how do we want to go? The high BC score will be in the center.
Okay, so if these two network are different, so we cannot infer one from the other, right?
Yes.
Because they are two different cases. So again, from what Dr. Fatima asked, why you want to study these two cases? Why you choose these two cases? Again, I want to know. Is it because prior from your research, you know these are two different network, or and if you know these two are different, so why are you studying these two different cases? So because I thought you want to improve one from the other.
I think the motivation is to apply the methodology into both networks. We will expect it will very different because it's protein and also user human interaction. But we want to test the methodology like the Fiedler algorithm with normalized cut and also the centrality, the degree betweenness and coarseness. So what we can have from that method, what we can have.
Okay, if you were asked to find to guess a similar kind of one of these interaction, what will you choose? A kind of network or community? Either close to this social interaction or with this human, protein interaction.
Yeah, maybe we can only focus on a social network, where we see a different network.
Different community.
Different community.
Okay. So the objective is just to test the method, alright? Okay.
Thank you, Dr.
I have one comment. One last comment. Actually, I think Dr. Sabri mentioned it also to one of the students. Because you were our undergraduate students, I do expect your references is correct. But unfortunately, again, most of them, I think all of them, is not complete. Okay?
Alright.
There's no. You have to indicate if it is a journal, then there must be volume issues and also page number. Okay. Alright.
Thank you,
Thank you,
Tasmi, Dr. Fatima. So we have come to the last but not least presenter.